Hi, my name's Ben Williams. I built this podcast to help me study for the Claude Certified Architect exam, which I passed in June 2026. Quick note, it was made by feeding the exam guide into Claude and generating the video with HyperFrames. So it follows the guide pretty much verbatim. It's not a replacement for working through the guide yourself, but helped me, especially on walks. If there's interest, I'll publish one for each exam domain too. I hope you get something out of it.
Welcome to the Architect's Notebook, the study companion for the Claude Certified Architect Foundations exam. I'm Maya, and as always, I'm the one in the room who has not passed this yet, so I get to ask all the questions you're probably thinking.
And I'm Theo. I build agentic systems for a living, and today my job is to get the whole syllabus into your ears in a way that actually sticks. So if you're walking the dog, doing the dishes, or commuting, you don't need a screen, just listen.
Let's set the scene first. What actually is this certification, and what does the exam look like?
Right, the Claude Certified Architect Foundations is for people who already have hands-on experience designing systems with Claude. Think 6 months or more of actually building things. It is not a beginner's badge. The exam itself is multiple choice. Every question gives you 4 options, and you pick the best one. Your score comes back on a scale from 100 to 1000, and you need 720 to pass.
720 out of 1,000, so roughly 72% feel.
Roughly, yes, though the scaled scoring means it is not a literal percentage. 2 things to tattoo on your brain about the format. First, there is no penalty for guessing, so you answer every single question, even the ones you're unsure of. Leaving a blank is just throwing away a chance. Second, the exam is scenario-based. You get a small number of detailed scenarios, and each one spawns a cluster of questions. So a scenario might be, you're building a multi-agent research system, and then 8 or so questions all drill into that same system from different angles.
So it rewards understanding the why, not memorizing trivia.
Exactly. The questions are almost always, given this situation, what is the best design choice? 2 answers will look plausible, 1 is subtly wrong. Your job is to know why. That's the whole game.
Before we dive in, give me the map. What are the big territories?
There are 5 exam domains, and they are weighted, which tells you where to spend your energy. Domain 1 is agent architecture and orchestration, and it's the biggest at 27%. Domain 2 is tool design and MCP integration, that's 18%. Domain 3 is Claude Code configuration and workflows, 20%. Domain 4 is prompt engineering and structured output, also 20%. And Domain 5 is context management and reliability, 15%.
So agents, tools, Claude Code, prompting, and context. If I add those up, orchestration and Claude Code and prompting are where most of the marks live.
That's the right read. But honestly, the domains overlap so much that if you understand the system end to end, you cover all 5. So let's just build the mental model from the ground up, starting with the engine underneath everything, the Claude API.
Okay, take me to the engine room. What happens when I send a request to Claude?
Picture a single API request. It carries a few key parts, the model you want, a max tokens value, which caps how long the reply can be, an optional system prompt, the messages array, which is the conversation so far, and optionally a list of tools, plus a tool choice setting. You send all that, you get 1 response back.
You said the conversation so far, so the model doesn't remember the previous turn on its own.
This is the single most important foundation, so let me say it loudly. The API is stateless. The model remembers nothing between requests. Every single time you call it, you must send the entire conversation history back, the whole thing. If you forget a turn, from the model's point of view, that turn never happened.
That feels like it would get expensive and long.
It does, and that tension drives half of the advanced topics we'll cover later, context management. But hold that thought. For now, just engrave it. State lives in your application, not in the model. You are the memory.
Inside that messages array, what are the roles?
3 roles: user, which is input from the human or your application; assistant, which is Claude's own replies; and tool, which carries the results of tools that were run. The conversation is just an alternating stack of these, and because it's stateless, you rebuild that stack every call.
Now there's this field everyone talks about, the stop reason. Why does it matter so much?
Because the stop reason is how Claude tells you why it stopped talking, and your whole control loop hinges on it. There are 4 values you need to know cold. End turn means Claude finished its thought naturally, it's done. Tool use means Claude wants you to run a tool before it can continue. Max tokens means it hit the length ceiling you set and got cut off. And stop sequence means it hit a custom stop string you defined.
So if I'm building a loop, the stop reason is my traffic light.
Perfect metaphor. If the stop reason is tool use, the light is green, go run the tool and come back. If it's end turn, the light is red, stop, the work is finished. We'll come back to this when we build the agentic loop, because getting this wrong is one of the classic exam traps.
Let's talk about the system prompt. How's that different from just a user message?
The system prompt sits separately from the messages array, and it sets the ground rules for behavior. Think of it as the standing instructions, the constitution. It takes priority over user messages, so you put role, tone, hard constraints, and policies there. One subtle thing the exam likes. If your system prompt overemphasizes a tool, say it gushes about how wonderful the search tool is, Claude may start overusing that tool even when it isn't needed. They call that a tool association side effect. The fix is to describe tools neutrally and let the criteria decide.
Sneaky, the system prompt can accidentally bias behavior.
Right, and that idea, that wording shapes behavior in non-obvious ways, runs through the entire prompt engineering domain.
Last piece of the engine, the context window, what exactly is it?
The context window is the total number of tokens the model can consider at once, your whole input plus its output. It's finite, and 3 things eat it alive. First, the lost in the middle effect. Models pay the most attention to the beginning and the end of the context, and information buried in the middle can get overlooked. Second, tool results pile up. Every tool call adds its output to the history, and verbose tools can flood the window with noise. Third, when you summarize old turns to save space, you lose specifics, exact dates, numbers, names.
So the context window is basically a small desk, and if you pile too much paper on it, things in the middle of the stack get ignored.
That's a lovely way to hold it. And the trick to working at that desk, putting the important papers on top and on the bottom where you'll actually look, is something we'll formalize later as position-aware input. Park that.
All right, the engine makes sense. Stateless model, you resend everything, the stop reason drives the loop, system prompt sets rules, context window is finite. Now tools. This is where it gets real.
Tools are how Claude reaches outside its own head. On its own, Claude can only produce text. With tools, it can search a database, call an API, run code, anything you let it. The mechanism is called tool use. And here's the part people get backwards. Claude does not run the tool. Claude generates a request that says, I'd like to call this tool with these inputs. Your application runs it and feeds the result back.
So Claude is the brain deciding what to do, and my code is the hands actually doing it.
Exactly the division of labor. Brain proposes, application executes, result returns, brain continues. Now, how does Claude know which tool to pick? Almost entirely from the tool's description.
Just the description, not the name.
The description is the primary selection mechanism. The name helps, but the description is what Claude reads to decide, is this the right tool for what I need right now? So a good tool description spells out what the tool does, what it returns, the input formats it expects, edge cases, and any constraints. And critically, descriptions must not overlap. If 2 tools have fuzzy, similar descriptions, Claude will sometimes pick the wrong one or dither.
So tool descriptions are basically prompts in disguise.
That's exactly the mindset. Write them like you're briefing a smart new colleague who can only see the description. Now, alongside tools, you control behavior with the tool choice parameter, and it has 3 modes worth knowing. Auto means Claude decides whether to use a tool at all. Any means Claude must call some tool, its choice which. And you can force a specific tool by name, which guarantees that exact tool runs, useful when you need a deterministic first step.
When would I force a specific tool?
Say every customer query must start by looking up the customer record. You force the lookup tool on the first step so it can't be skipped. After that, you might switch back to auto. Forcing is about enforcing order and guarantees.
Now there's this idea of using tools just to get clean structured output, even when there's no real external action. Explain that.
This is a beautiful trick. You can define a tool whose only purpose is to shape the output. You give it a JSON schema, the fields you want, their types, which are required. Then you force that tool. Claude fills in the schema, and because the schema is enforced at the tool layer, you are guaranteed syntactically valid JSON. No more passing a blob of text and praying it's well-formed.
So the schema guarantees the shape. Does it guarantee the content is correct?
And here's the exam trap beautifully. No, a schema guarantees syntax, not semantics. It guarantees you'll get a field called price that is a number. It does not guarantee the number is the right price. Claude could still hallucinate a value that fits the type, but is factually wrong. Syntax errors, malformed JSON, are eliminated. Semantic errors, wrong values, still need validation.
Say that distinction again, because I bet it's worth points.
Syntax versus semantics. Tool use plus a schema kills syntax errors. It does nothing for semantic errors. To catch wrong values, you validate afterward, and we'll cover validate and retry in the prompting section. Now, a few schema design touches the exam loves. Mark fields required only when they truly must be present. For a field that might be genuinely empty, allow null, by typing it as string or null, rather than forcing Claude to invent something. For categories, use an enum, but include an other option, and often an unclear option, so the model has an honest escape hatch when the input doesn't fit or it isn't confident.
That unclear option is interesting. You're giving the model permission to admit doubt.
Which is far better than forcing a confident wrong guess. A model with no out will jam a square peg into your nearest category. Give it unclear, and you can route those cases to a human. That theme, designed so the model can express uncertainty, comes back again and again.
Okay, we've got the engine and we've got tools. Now let's assemble them into an actual agent. What's the agentic loop?
This is the heart of Domain 1, so let's go slow. An agentic loop is a 5-step cycle. Step 1, you send a request to Claude with the conversation and the available tools. Step 2, Claude responds. Step 3, you check the stop reason. Step 4, if the stop reason is tool use, you execute the requested tool. Step 5, you append the tool's result to the conversation and loop back to step 1. You keep going around until the stop reason is end turn.
So the loop is literally driven by the stop reason.
Driven entirely by the stop reason, and this is where I need to warn you about the anti-patterns because the exam adores them. Anti-pattern 1, passing Claude's text to decide if it's done, like scanning for the word finished. Don't. The completion signal is the stop reason equals end turn, not some phrase in the prose. Anti-pattern 2, hard coding a fixed number of iterations, like always loop exactly 3 times. That breaks the model-driven nature. The model decides how many steps it needs. Anti-pattern 3, building a rigid decision tree of if this then, that for every tool. You let Claude choose the tools based on their descriptions.
So the whole philosophy is, trust the model to drive and just react to the stop reason.
That is the philosophy in one sentence. Model-driven, not hard-coded. If you see an answer that involves text passing for completion or a fixed iteration cap, it's almost certainly the wrong answer.
Now scale it up. One agent is fine, but the exam loves multi-agent systems. How do those work?
The standard pattern is hub and spoke, also called coordinator and subagents. You have one coordinator at the center, the hub. It talks to the user, breaks the big task into pieces, and hands each piece to a specialized subagent, the spokes. The subagents do their focused work and report back. The coordinator aggregates everything and handles errors.
So the coordinator is the project manager, and the subagents are the specialists.
Exactly, and now the single most tested fact in this entire domain, so lean in. Subagents have isolated context. They do not automatically see the conversation history. They do not see what other subagents found. Each one starts fresh, knowing only what the coordinator explicitly tells it.
Wait, so if the coordinator knows the customer's name and the order number, the subagent doesn't know those unless the coordinator passes them along.
Correct, and that is the trap in maybe a quarter of the orchestration questions. Context is not inherited. It must be explicitly passed. If you spawn a research subagent and just say, "Look into this," with no specifics, it has no idea what this refers to. You have to hand it the full brief. Good delegation reads like, "Research the third quarter revenue figures for company X using these sources and return a table." Bad delegation reads like, "Continue the research."
And the coordinator is also the gatekeeper for communication.
Yes, subagents generally don't talk to each other directly. They go through the coordinator. The coordinator is the only one with the full picture. That keeps the system understandable and keeps each subagent's context small and focused.
How do you actually configure these agents?
Through an agent definition. The key fields are a name, a description of what the agent is for, a system prompt that sets its behavior, and an allowed tools list. That allowed tools list is your security boundary, and you apply the principle of least privilege. A subagent that only reads files should not have write or delete tools. The coordinator might have the ability to spawn subagents, while the workers have only the few tools their job needs.
In spawning a subagent, how does that happen mechanically?
Through the task tool, the coordinator calls the task tool to launch a subagent. Two things the exam checks here. First, for a coordinator to spawn subagents, its allowed tools must include the task tool itself. If task isn't in its toolset, it literally cannot delegate. Second, you pass the full context in that task call because, remember, the subagent inherits nothing. And if you want subagents to run in parallel, you simply make multiple task calls at once. They execute concurrently.
So parallelism is just fire several task calls together.
That's simple. 3 independent research streams, 3 task calls in one go. They run side by side, and the coordinator collects all 3. Now there's one more powerful tool in the agent SDK Hooks.
Hooks, what problem do they solve?
Hooks let you intercept the system's behavior with deterministic code rather than hoping the prompt behaves. The classic one is a post-tool use hook. It fires every time after a tool runs, and you can transform the result before it goes back to Claude. For instance, normalize every timestamp to a standard format, or strip a bloated API response down to the 5 fields that matter.
And you said deterministic. That's the keyword versus a prompt.
That is the whole comparison, and it's a likely exam question. Hooks are deterministic. They run as code every time, guaranteed. Prompt instructions are probabilistic. The model usually follows them, but not with certainty. So the rule of thumb. If something is a critical rule that must always happen, a refund cannot exceed $500, identity must be verified before any account change, you enforce it with a hook or with code, not with a polite line in the prompt. If it's a soft preference, prefer a friendly tone, a prompt instruction is fine.
Critical guarantees go in code. Preferences go in prompts. Got it. Let me try to break it. If I write in the system prompt, never issue a refund over $500, is that enough?
That is the trap answer. It's not enough because it's probabilistic. The model will usually obey, but usually is not a guarantee, and money is involved. The robust design puts that $500 ceiling in a hook that intercepts the refund call and hard blocks anything over the limit. Prompt for the spirit, code for the guarantee.
Beautiful. Let's move to MCP. What is the Model Context Protocol?
MCP is an open protocol for connecting Claude to external systems in a standard way. Instead of every integration being a bespoke snowflake, MCP gives a common shape, and an MCP server can expose 3 kinds of things. Tools, which are actions, like create a ticket or query the database. Resources, which are data Claude can read, like documentation, schemas, or catalogs. And prompts, which are reusable templates.
Tools, resources, prompts, so it's not just about actions.
Right, and the resources part is underrated. We'll come back to it. An MCP server is just a running process that Claude can connect to. When it connects, the tools that server offers are discovered automatically and become available, and you can connect several servers at once. All their tools are simultaneously available, and Claude picks between them, again, based on descriptions.
How do I configure these servers?
Two scopes, and the difference matters. Project scope lives in a file called .mcp.json at the root of your project. Because it's in the project, it goes into version control, and the whole team shares it. User scope lives in the claude.json file in your home directory, and it's personal to you, not shared. And for secrets, you never hard code a token. You use environment variable substitution, so the config references something like the GitHub token variable, and the actual secret stays in your environment.
So team-wide server, put it in the project file in version control. Personal server, put it in your home config.
Precisely, and a guiding principle the exam likes. Prefer a well-maintained community MCP server over writing your own from scratch when a good one exists. Don't reinvent the integration. Now, error handling in MCP, there's a flag called isError.
Tell me about it.
When a tool fails, the response can carry an isError flag set to true. But the trap here is a bare isError with a vague message like operation failed is almost useless. The model can't decide what to do next. A good error is structured. It tells you the error category, whether it's retrievable, a clear message, maybe the query that was attempted, and any partial results. With that structure, the coordinator can make a smart decision, retry this, escalate that, or use what partial data came back.
So generic errors are an anti-pattern. Errors should be informative enough to drive a decision.
That's the through line of all the error handling topics. An error is not just a failure, it's information for the next decision. Now, the last MCP piece, resources, the underrated one. A resource lets Claude read a body of reference data directly, a database schema, a catalog of tasks, an internal doc. The advantage. Instead of Claude making a dozen exploratory tool calls to figure out the lay of the land, it just reads the resource once and knows the structure. It saves round trips and context.
So if a question is about Claude wasting calls exploring, a resource might be the elegant fix.
Often, yes. Give it the map up front instead of making it wander. All right, that's MCP. Shall we move into Claude Code itself, the configuration domain?
This is 20% of the exam, so I want it solid. Start with the famous Claude.md file.
The Claude.md file is how you give Claude Code persistent instructions about your project. And the crucial concept is the hierarchy, 3 levels. User level lives in your home directory, in your personal Claude config folder, and it's just for you, it is not shared with the team. Project level lives in the project, either in the .claude folder or at the root, and because it's in version control, the whole team gets it. And directory level, you can drop a Claude.md inside a subdirectory, and it applies conventions just for that part of the codebase.
Give me the scenario that tests this, because I can feel one coming.
Here it is. A new team member joins, and Claude isn't following a convention that works fine on your machine. Why? Because you put that convention in your user-level config, which is personal and not shared. The fix is to move it into the project-level Claude.md, which is version-controlled, so everyone gets it. Personal versus shared, that's the whole question.
User level is personal, project level is shared in version control. So team conventions must live at project level.
Nailed it. Now, a feature to keep that file from becoming a monster. The @path import syntax. Inside a Claude.md, you can write then a relative path to another markdown file, and it pulls that file's contents in. So you keep a lean main file that imports modular pieces, and a PI conventions file, a testing file, and so on. Relative paths are preferred, and there's a depth limit. Imports can nest up to 5 levels deep.
So instead of 1,000-line config, you compose smaller files with @path imports.
Exactly modular configuration. And there's an even more targeted mechanism, the .claude/rules folder. Instead of one big file, you put topic-specific rule files in there. And the clever part, each rule file can have a little YAML header, front matter, with a paths pattern. So a rule only loads when you're working on files matching that glob.
Give me a concrete example.
You have a testing rules file whose paths pattern matches anything ending in .test.tsx. That rule only activates when Claude is touching test files. Your React patterns file only loads for component files. The benefit is huge. You're not burning context on React rules while editing a database script. It's conditional, path-based loading. Compared to a directory-level Claude.md, which loads for everything in that directory, the rules folder with path patterns is more surgical.
So path-scoped rules save context by only loading when relevant. Now, /commands and skills, what's the difference?
There's a legacy format and a current one. The older way was a .claude/commands folder, where each file was a custom /command. The current, richer way is skills in a .claude/skills folder. A skill is a folder with a skill.md file that has front matter configuring how it behaves, and there are a few settings worth knowing. Context fork means the skill runs in an isolated subagent with its own clean context, so it doesn't pollute your main conversation. Allowed tools restricts which tools that skill can use, a security control, and an argument hint prompts the user for the parameters the skill needs.
When would I want context fork?
When a skill does a big, messy investigation that would otherwise flood your main context with noise, fork it, let it churn in isolation, and only the clean result comes back. It's the same context protection idea as delegating to a subagent, and the distinction the exam wants. A skill is an invocable, parameterized action. You call it with its name. A Claude.md is passive standing context that's just always there. One is a verb you trigger, the other is background knowledge.
Skill is a verb you invoke, Claude.md is ambient context. Good. Now, planning mode versus just doing it.
Planning mode is a mode where Claude investigates but makes no changes. It can read files, grep, glob, explore, understand the problem, and propose a plan, but it won't edit or write anything until you approve. It's safe exploration, no side effects. Direct execution is when the fix is obvious, a clear stack trace, a tiny change, and you just let it act.
So planning mode is, look before you leap on a big or risky change.
Right, and the combined workflow is common. Plan first, review the plan, approve, then execute. For gnarly refactor across many files, you absolutely want the plan and approval gate. For a one-line typo fix, direct execution is fine.
A couple of commands now, /compact.
/compact compresses your conversation history, summarizing it to free up context space. Incredibly useful when a long session is filling the window, but the trap, it's lossy. Summarizing can drop exact details, specific dates, precise numbers, names. So if you're mid-investigation and those specifics matter, compacting can quietly lose them. We'll see the defensive technique for that shortly, the case facts block.
And /memory.
/memory lets you edit and persist things into the Claude.md so they stick across sessions. It's how you save a preference or a piece of project context for next time. Compact compresses the current session, memory persists across sessions, different jobs.
Now /cd. Claude Code in a pipeline. That sounds advanced.
It's simpler than it sounds, and it's testable. To run Claude Code non-interactively in a script or pipeline, you use the -p flag, also written as print. It runs the prompt and prints the result to standard output without waiting for an interactive session. You can add output format JSON to get machine-readable output, and a JSON schema flag to validate that output against a schema. The classic use case is an automated code review that runs on every pull request.
And each of those review runs is independent.
Yes, and that independence is a feature. Each review instance is its own session, so it isn't biased by a previous run's context. If you want to include the standards, you document your testing conventions and make fixtures available so the review has what it needs. fresh, isolated, schema validated. That's the CI shape.
Last config piece sessions, resume and fork session.
You can continue a previous session with the resume flag and a session name, which restores the saved context so you pick up where you left off. The risk: the restored context might be stale, the code may have changed since. Fork session lets you branch an investigation, you split off from a point and explore a different direction without disturbing the original. The decision: start a new session when the task is genuinely fresh, resume when you need the prior context, and fork when you want to branch an existing line of inquiry.
Okay, my brain is full but holding. Let me recap the Claude Code domain. Claude.md has 3 levels: user personal, project shared, directory local. At path imports, keep it modular. The rules folder with path patterns loads conditionally. Skills are invocable forked actions. Planning mode explores safely. Compact is lossy compression, memory persists. And -p runs it in CI with JSON output.
That is a clean summary. You just narrated 20% of the exam, ready for prompt engineering, another 20%.
Let's do it. Where do we start?
Start with the single highest leverage idea in the whole domain. Explicit criteria beat vague instructions. If you tell Claude be more conservative or use good judgment, you'll get inconsistent results, because those words mean different things every time. Instead, you specify exact rules. What to report, what to ignore, with concrete thresholds and examples.
Give me the before and after.
Before, in a code review prompt, be more careful about security issues. Vague, unmeasurable. After, report any SQL query built with string concatenation as critical. Report missing input validation on user-facing endpoints as high. Ignore style preferences entirely. Now Claude has a rubric. And notice you can define severity levels with examples: critical, high, medium, low, each with a sample of what qualifies. That tightens consistency and controls your false positive rate.
So when an answer choice says, just tell it to be more careful, that's the weak option.
That's the weak option almost every time. The exam rewards specificity. Vague adjectives lose, explicit criteria win. Next technique, few-shot prompting. You give Claude 2 to 4 examples of input and the desired output. Examples are often far more effective than describing the behavior in words.
Why are examples better than just explaining?
Because they pin down the exact format and the exact judgment calls, including the tricky edge cases that prose glosses over. And the key principle: Claude generalizes from good examples, it doesn't just parrot them. So you choose examples that demonstrate the pattern, not every literal case. There are a handful of things few-shot examples are great at showing: how to handle an ambiguous input, the exact output format you want, the line between acceptable and problematic code, how to extract data from messy, varied document formats, and how to normalize informal units, like turning a couple thousand into a number or standardizing dates and currencies.
How many examples ballpark?
2 to 4 is the sweet spot the material emphasizes. Enough to establish the pattern, not so many you bloat the prompt. And pick diverse examples that cover the tricky cases, not 3 near-identical ones.
Next, prompt chaining.
Prompt chaining is breaking a complex task into a sequence of focus steps where each step's output feeds the next. The reason: attention dilution. If you ask one prompt to do 5 things at once, quality on each drops. Split them. Step 1 extracts the data. Step 2 validates it. Step 3 formats it. Each step has the model's full attention.
When wouldn't I chain?
When the steps are knowable and fixed in advance, chaining is perfect. It's predictable and reproducible. But if the subtasks depend on what you discover along the way, you want dynamic decomposition instead, which we'll hit in the task decomposition section. Chaining is a fixed pipeline, known steps, in order. There's also a nice variant, the integration pass. When you review files one by one, you can miss issues that span multiple files, so you add a final pass that looks across everything for cross-cutting problems.
Then there's something called the interview pattern. That one's intriguing.
I love this one. The interview pattern is when you have Claude ask you clarifying questions before it starts building, rather than charging ahead on assumptions. It's ideal when the domain is unfamiliar or there are several viable approaches or key context is missing. So instead of guessing, Claude asks, what's your caching strategy? How much data are we talking about? What's the expected load? Then it builds the right thing the first time.
So when a problem is underspecified, the smart move is to ask, not assume.
That's the lesson, and it mirrors good engineering. Now, validation and retry with feedback. This is a big one, and it pairs with structured output. The pattern is 3 steps. Extract, get the structured output from Claude. Validate, check it against your rules. And if it fails, retry. But, and this is the key, you put the specific error into the retry prompt.
So you don't just say, try again. You say, try again, and here's exactly what was wrong.
Precisely. The total was supposed to equal the sum of the line items, but you returned 100 and the items add to 90. Please correct. With that feedback, Claude usually fixes it. Now, when does retry actually help, and when is it pointless? Retry helps for format problems, structural problems, and arithmetic slips, things the model can fix by looking again. Retry does not help when the information is simply missing or requires external context the model doesn't have. You can't retry your way to a fact that isn't there.
That's a sharp distinction. Retry fixes reasoning and format errors, not missing knowledge.
Exactly, and in Python, the tool people use for this is Pydantic. It does structural validation, checks types and required fields, and supports custom validators for semantic rules, like the total must equal the sum. You can even generate a JSON schema from a Pydantic model and build a validate and retry loop around it. If you see Pydantic in an answer about enforcing and validating structured output, it's usually pointing the right way.
And self-correction.
A neat pattern, you have the model output both a stated value and a calculated value, plus a field that flags any conflict between them. If the model says the total is 100, but also computes 90 from the parts, the conflict field catches it. You're building the cross-check into the output itself.
Smart, okay. Let's switch gears to the batches API because cost comes up.
The message batches API lets you submit a large number of requests for asynchronous processing, and you get a 50% cost saving. The trade-off, it runs within a 24-hour processing window with no latency guarantee. It might come back in 20 minutes, it might take hours. And one hard limitation to remember, batch does not support multi-turn tool calling. It's for independent, one-shot requests, not back-and-forth agentic conversations.
So the decision is basically, can I wait?
That's the whole decision. If a human or a process is blocked waiting on the result, a pre-merge check before code can ship, use the synchronous API. If it's a non-blocking job that can run overnight, classify 10,000 documents, generate a morning report, use batch and pocket the 50%. Developer waiting, synchronous, fire and forget, batch.
And how do I track which result is which in a giant batch?
With a custom ID, you attach a custom ID to each request, your own identifier, like the document ID. When results come back, possibly out of order, you match them by custom ID, and it's essential for failure handling. Say 95 of 100 succeed and 5 fail. You identify the 5 by their custom ID, and you resubmit only those 5, maybe with a tweak, like chunking an over-long document. You don't reprocess the 95 that worked.
Partial success, resubmit only the failures, and SLA planning.
Simple arithmetic, but they test it. The window is up to 24 hours, so you plan backward from your deadline and add a buffer. If something is due in 30 hours and processing can take 24, you must submit within the first several hours to leave room, plus a margin for resubmitting failures. So you submit early and often.
Let's tie off task decomposition properly, since you keep referencing it.
Yes, let's make it crisp, because it's a recurring decision. 2 main strategies. Fixed pipelines, which is just prompt chaining, you know all the steps in advance, and they run in a predictable order. Great when the process is stable and repeatable. The other is dynamic adaptive decomposition, where you generate the subtasks based on what you discover at runtime.
Give me the dynamic example.
Testing an unfamiliar legacy codebase. You can't know the steps up front, so step 1, discover the structure. Step 2, based on what you found, prioritize the risky modules. Step 3, adapt to the dependencies you uncover, and so on. The shape of the work emerges from the work itself. Use dynamic decomposition for open-ended investigation where the scope is unknown. Use fixed pipelines when the steps are known and stable.
And multi-pass review keeps coming up too.
Because it's the answer to a whole family of questions. When reviewing code, a single pass trained to catch everything suffers attention dilution, so you split into passes. A per-file pass catches local issues inside each file. Then an integration pass looks across files for inconsistencies, contradictory patterns, an interface used differently in 2 places. 2 focused passes beat 1 overloaded pass. Same principle as prompt chaining, focus beats breadth.
Now, escalation and the human in the loop. When should an agent hand off to a person?
This is a favorite, especially in the customer support scenario. There are reliable triggers for escalation and unreliable ones, and knowing the difference is the test. Reliable triggers. The customer explicitly asks for a human. There's a policy gap. The situation isn't covered by the rules. The agent genuinely can't make progress. A financial threshold is crossed, like a refund above a limit. Or there's ambiguity the agent can't resolve, like multiple customers matching the same name.
And the unreliable triggers.
The trap triggers don't escalate based on detected sentiment. The customer sounds a bit annoyed. Don't escalate based on the model's own self-rated confidence. I'm only 70% sure. And don't lean on a separate sentiment classifier as your gate. These are noisy and unreliable. Escalate on concrete, verifiable conditions, an explicit request, a policy gap, a threshold, a true ambiguity, not on vibes.
So if an answer says, escalate when the model reports low confidence, that's suspect.
Suspect indeed. Self-reported confidence is not a reliable escalation trigger. Now, the patterns of escalation. Sometimes you escalate immediately. When the customer explicitly demands a human, you don't make them fight a bot. Sometimes you attempt to resolve first, then escalate if the customer is still unhappy. And there's a nuanced one. Acknowledge the emotion, offer a solution, and only escalate if they reiterate. You don't bail to a human at the first sign of frustration, but you also don't trap someone who clearly wants out.
And when you do handoff, how do you do it well?
With a structured handoff, you give the human a self-contained summary as structured data. Customer ID, a summary of the issue, the order ID, the root cause, actions already taken, any refund amount, a recommended next action, and the reason for escalating. The critical word is self-contained. The human should not have to read the entire chat transcript to get up to speed. Everything they need is in the summary.
That self-contained idea echoes the subagent thing, doesn't it? Pass everything explicitly.
You're seeing the deep pattern now. Whether it's a subagent or a human, the receiver has limited context, so you hand them a complete, structured brief. Same principle, different recipient, and related confidence calibration for oversight. When you're processing lots of items, you attach a confidence score per field. You calibrate those scores against a labeled validation set so they actually mean something, and you route low confidence items to human review.
How do you check the system is accurate overall?
You don't trust a single aggregate number because a high average can hide a weak spot. You use stratified random sampling, sample across different document types, and break the error rate down by type and by field. Maybe you're 99% accurate on invoices, but 70% on handwritten forms. The aggregate hid that. Stratify to find the weak pocket.
Great. Let's go to error handling in multi-agent systems, because you keep teasing it.
Let's make it concrete. There are 4 error categories, and each has a correct response. Transient errors, a timeout, a 503, these are temporary, so you retry them. Validation errors, a bad format or a missing field, you fix the input and retry. Business errors, a policy violation, or a threshold breach, you do not retry, you escalate, because retrying won't change the policy. And permission errors, access denied, also no retry, escalate.
So retriable versus not is the key axis. Transient and validation, retry. Business and permission, escalate.
That's the cheat sheet. Now the anti-patterns, because the exam loves to show you bad error handling and ask what's wrong. Anti-pattern 1, a generic status like unavailable that hides whether it's retriable. Anti-pattern 2, silent suppression, swallowing an error and returning an empty result as if it succeeded, which destroys the distinction between found nothing and failed to look. Anti-pattern 3, aborting the entire workflow because one subtask failed when you could have continued with partial results. And anti-pattern 4, infinite retries on a subagent that's never going to succeed.
That second one is subtle. An empty result and a failure look the same to the next step.
And that confusion is dangerous. There were 0 fraudulent transactions is a very different statement from I couldn't access the fraud database. If you return an empty list for both, the coordinator might happily report all clear when really it just couldn't check. So a subagent error should be structured, status, the failure type, the query it attempted, any partial results, alternative approaches it suggests, and the coverage impact. That lets the coordinator decide intelligently and degrade gracefully, use what you've got and clearly flag what's missing.
Which leads to coverage annotations.
Right, when you can't fully complete something, you annotate the gap honestly in the report. This section is fully covered. This section is partial, with a warning note that source X was unavailable. You never silently present partial data as if it were complete. Transparency about what you couldn't reach is itself a feature.
Okay, the home stretch. Context management in production, this ties back to that finite desk.
It does, and there are several techniques, all defending the context window. First, extract facts into a separate block. You maintain a structured block, something labeled case facts, that holds the essential stable facts, the customer ID, the account type, key decisions, and you include it in every prompt. Why? Because when you compact or summarize, that block survives, so the crucial facts don't get lost in lossy summarization.
So the case facts block is the antidote to compact being lossy.
Exactly the antidote. Second technique, trim tool results. Use a post tool, use hook to cut a bloated result from 40+ fields down to the 5 you actually need. Less noise, more room. Third, position-aware input. Remember lost in the middle. So you place key findings at the top, supporting detail in the middle, and action items at the end, exploiting the fact that the model attends most to the start and the end.
Important stuff at the top and bottom, filler in the middle.
That's the practical rule. Fourth, scratchpad files. In a long investigation, you write key discoveries to a file, so even if the conversation degrades or gets compacted, your findings persist outside the context window and can be reread. Fifth, and we've met it, delegate to subagents to protect context. Send an exploration off to a subagent that reads 15 files, and it returns one clean line, instead of dumping 15 files into your main context.
The subagent absorbs the mess and hands back the gist.
Beautifully put. And sixth, structured state persistence. For long or crash-prone work, you export state to a known location, a JSON manifest, so you can resume after a crash, and the coordinator can track each subagent's status. State lives in a durable file, not just in volatile context.
Then there's provenance. Why does that get its own topic?
Because in research and analysis systems, the link between a claim and its source decays as information flows through summaries and subagents. Preserving provenance means every claim carries its origin. A bad output says, revenue grew 20%, with no source, no date. A good output attaches the source name, the source URL, the publication date, and a confidence level, so you can trust it and trace it.
And conflicting data.
You don't silently pick a winner. You present both values, each with its source and methodology, flag that they conflict, offer a possible explanation, and defer the final call to the coordinator or the human. And dates are crucial here because two different numbers might not actually contradict. One is this year's figure, one is last year's. With the dates attached, that's growth over time, not a contradiction. Without dates, it looks like an error.
So include dates, so a difference can be interpreted as change rather than conflict.
Exactly, and one more touch, render by content type. Financial data belongs in a table, news and analysis read better as prose, technical findings as a list, time series in chronological order. Match the format to the nature of the data.
Last domain piece, the built-in tools in Claude Code, quick fire.
Quick fire it is. Glob finds files by a name pattern like all the test files. grep searches for content inside files, a string or a pattern. Read loads a full file. Write creates a new file. Edit makes a precise change to an existing file. And bash runs shell commands. Pick the narrowest tool for the job.
And there's a recommended way to use them together.
Incremental investigation. Don't read every file at once. That floods context and is wasteful. Instead, grep to find the relevant spots. Read just those. Grep again based on what you learned. Read the next layer. You build understanding in layers, pulling in only what you need. And a useful fallback. When edit fails because the text you're matching isn't unique, you fall back to reading the whole file and writing the updated version. Read plus write when a precise edit can't pin the location.
Okay, we've walked the entire syllabus. Can we do a lightning round of the traps, the things most likely to cost me points?
My favorite part. Fire away, I'll give you the trap and the truth.
Detecting completion in an agentic loop.
Trap, pass the text for a word like done. Truth, check the stop reason equals end turn.
Subagent context.
Trap, assume it inherits the conversation. Truth, it's isolated, you must pass context explicitly.
Enforcing a hard money limit.
Trap, write it in the prompt. Truth, enforce it in a hook or code deterministically.
Structured output via a schema.
Trap, assume the values are correct. Truth, syntax is guaranteed, semantics still need validation.
A vague instruction, like be more careful.
Trap, that's fine. Truth, replace it with explicit criteria and examples.
When to escalate to a human.
Trap, on low confidence or negative sentiment. Truth, on explicit request, policy gap, threshold, or true ambiguity.
A team convention Claude won't follow for a new hire.
Trap, something's broken. Truth, it's in user-level config, move it to the project-level Claude.md in version control.
Batch versus synchronous.
Trap, batch is just the cheaper default. Truth, batch is for non-blocking jobs within 24 hours, and it can't do multi-turn tools. Anything a developer waits on goes synchronous.
An empty result from a tool.
Trap, treat empty as success. Truth, distinguish found nothing from failed to look with a structured error.
Saving context in a long session.
Trap, just keep compacting. Truth, compact is lossy, protect the essentials with a case facts block, scratchpad files, and subagent delegation.
That is a phenomenal list. Any final exam day advice?
3 things. 1. Read each scenario carefully. The details are clues. A mention of a refund limit is hinting at hooks. A mention of a new team member is hinting at config hierarchy. 2. When 2 answers look right, pick the one that's deterministic, least privilege, explicit, and honest about uncertainty. That's almost always the Claude way. And 3. Answer every question. There's no penalty for guessing, so never leave a blank.
Deterministic, least privilege, explicit, honest. That's a mantra.
That's the architect's mindset in 4 words. If a design choice is more guaranteed, more scoped, more specific, and more transparent about what it doesn't know, it's probably the right answer.
Theo, this was brilliant. Let me give the listener the closing recap. The model is stateless, you resend the whole history, and the stop reason drives the loop, end turn means stop. Tools are brain proposes, app executes, and descriptions are how Claude chooses. Multi-agent is hub and spoke. With isolated subagent context you must pass explicitly. Guarantees go in hooks and code, preferences in prompts. MCP standardizes external connections with tools, resources, and prompts, and errors should be structured. Claude.md has a 3-level hierarchy: user personal, project shared, directory local, with modular imports and path scoped rules. Prompting wins with explicit criteria, few-shot examples, chaining, the interview pattern, and validate and retry with feedback. Batch saves 50% for non-blocking jobs. Escalate on concrete triggers, not sentiment or confidence. Handle errors by category and never hide failures behind empty results. And protect your context with fact blocks, trimming, position awareness, scratchpads, and delegation.
If you can hold that recap in your head and you understand the why behind each piece, you are in genuinely strong shape for 720. Go pass it.
That's the Architect's Notebook. Listen again before exam day and good luck. You've got this.
Thanks for sticking with it. That's a fair bit of ground to cover in one sitting. If it was useful and you want to keep going deeper on Claude, subscribe to the channel. There's more study material there, and I also put up live builds, real projects start to finish, where you can watch the thing get made and see what breaks along the way. That's the stuff you don't really get from a guide. No pressure either way. Good luck with the exam.